Good evening, everyone, and welcome to another episode of Technology FM. Today we'll be talking about another exciting episode uh, about the topic that speaks to data reliability, where it meets AI, and we'll be talking generally about building a scalable, intelligent infrastructure system for the next decade. It's going to be more of conversation for today. And today I have someone that I've worked with in the past, who happens to work in the Middle East, and is someone that I respect so much in the industry. I have on the show today Godwin. Godwin happens to be a data engineer, which I've worked in both Nigeria, Middle East, and currently based in United States of America, where he's doing some cool stuff regarding data, and he has been doing that for some time now. Today, I'm happy that he's able to join me on the show to come and talk regarding data reliability and AI. Godwin, thank you for joining us today.
Yeah, Bartende, thank you for having me. It's a great privilege to share little insights of my journey in the data space and in the tech space and how it has shaped my way of viewing the impact of data and the impacts in the business and impacts in the future about AI and a lot of cool stuff that has been built based on working with data. Thank you for having me.
Thank you, Godwin. We just go into it. So it's going to be nice for us to even know more about you, how you started, what changer you into technology, from database to data, into doing a lot of reliability solutions. Now, we just want to know about you. Can you just tell us about yourself? What basically makes you to come into the world of technology?
Yeah, the world of technology can be dated far back to my time in GT Bank. You understand? That's where I started my core tech career. Because after I was done with school, NYSC and stuff like that, so I got into GT Bank Tech Academy. I was more interested in software development, stuff like that. But then I started a data team whereby we are part of the core database team and core banking support at GT Bank. And one exciting thing then was that the period I came into GT was one they were running a very, very significant core project. So it was an upgrade from Oracle 11G to Oracle 19C. And
Wow.
that was when I began to understand how there is a there is very, very significant impact in the data speed, not just the application, the software part, but there are some other component that is very, very important in making the whole system work. And I saw the impact of what we are doing to the banking system because if anything goes wrong, the whole bank system goes bad. So at that period, I get to work with some well experienced guy, top software and database engineer from Oracle, from ICS, and it gave me the exposure of firstly how important data reliability is. You understand? Data reliability is that any core organization cannot run effectively without the core system, and the core systems are the infrastructure itself, the data itself, the network itself, and the application itself. And those things couple together to provide a reliable system. So now when we now dissect into data reliability, we look at the data itself, how reliable it is, how accessible it is for the application, how we can get data in a very low latent way, and also availability in terms of when by you look at the disaster recovery parts, maybe in case there's a failure at any point, is it a single failure system? Is it more of a distributed system? How do we partition or separate the data into different platforms to improve our system? So in those periods, I was exposed to a lot of technology, a lot of, firstly, in that period, I didn't understand the core system is about your what, how did you design your system? Not just the system design, how do you design your database system, your database model, how does each entity relate with one another,
Yeah.
the the core system behind it. When each entity, just like, let's come to the basics. The table whereby you store your data. How does one table relate with another table? How do you join the table? Setting up. Then I begin to understand that, we have separate system. We have the OLTP system, more like a system built for frequent writes, whereby you have core updates, like whereby the banking system, financial system, by people come into the system, do their banking stuff. They need to get their current balance. They need to do the debit, stuff like that. Then you also have another system, which is called the OLAP system. This is more designed for analytics. So that means data can serve in two different ways. Data reliability serving, providing your user base experience, like in your application, the core system running, then also in the analytics part, trying to understand your data, trying to understand your customer base, trying to help the firm itself if you want to push in product, because there's a time they push a product about the quick credit. It was based on the analytical part, whereby you understand your customer base. From there, you could build um, one kind of model whereby you can give credit to particular people who fit that particular threshold. So you have to understand, okay, what's the purpose of this system? What am I building it for? Am I building it for a core read frequent writes, or more for analytical purpose? So then it exposed my mind about, there are separate way you can serve this data. Now, in serving the data, we now look at the availability itself. How do you make this data available?
Okay.
How do we design the infrastructure behind it? You understand? So some people, they have their own. Then when I was working in Digital Bank, we have our own in-house data um, data center, whereby you have your server running. Then how do you design those things? Why some people you can build on cloud-based technology, but what is more important is your infrastructure. How available it is. Is it strong enough to deal with the requests, the resource base? You have to start thinking about allocation of resource. How does this system? Then also you have to design the availability itself. Maybe you want to have it in different zone for reliability, in terms of in case you don't have a single point of failure. So those periods now expose my journey in the
A
data
lot of
world.
things.
A lot of things, like, no, we are talking about software engineering, which was my interest, but when I came to data world, like, wow, this is a big thing. With a big thing. And also when the recent trend about AI, when ML was machine learning was coming on, you can't even build a machine learning system without your data. You understand? So you see, from getting users' data, storing it up so that you can serve it right, and you picking the data, designing a system whereby you can understand pattern, that also push a new product and make
Okay.
good improvement or add new features. So they are being to understand that, this thing is a big space, and you have to now choose, okay, how you deal with it. Then also, then in GT Bank, then I have to move to a different team whereby I handled the database system for all the e-application, so on SQL Server then. And I begin to understand that, there's some system how you can do, there's a project I did about archiving, as
Okay,
there are
data
sometimes
governance.
when you have a very large table, it slows down requests. So what you need to do is like, okay, how do you design an archiving system? What archiving system means in a layman terms, those data that are not frequently read, how do you put them to a code state whereby you just access it once in a while? Why we keep the important data that are frequently read? Then how do we schedule it? How frequently should we schedule it without impacting our system? So then I need to understand, there are a lot of techniques how you can design your system, the availability, the uptime, and also archival, picking some data in code states. And in all those things, to the business side, you have to like minimize costs. How do we allocate resource, you understand? And how do we know system that we need to allocate more resource to, and system we need to allocate lesser resource? So those things give me deeper understanding about how we can design the data model itself, the infrastructure behind it, and how we can store the data into different storage system. So then moving forward, then I moved to Bahrain where we get to meet, where we are working on a lot of projects, smart money, new
Yeah, lots
PFC
of things.
product. Yeah.
Yeah,
So in that space, we're now working on migration. So we're moving from the on-prem to AWS system, and we are moving away from Oracle to SQL Server to Postgres on RDS, SQL Server on EC2. So then in that same project, now expose me, okay, how do we seamlessly migrate a system from our own end server to a cloud platform in a way whereby it won't affect our product. And in a way whereby, since we are coming from, the design from the current system, the design,
totally
the
different.
model design is totally different from there. So you start understanding, oh, which data am I pulling? Which data is similar? You now do like your mapping. You're mapping this
Data
design to this
mapping and the
current
likes.
data mapping.
So let me stop you there and quickly ask you a question. Yeah. So I know that you are able to achieve those stuffs then, but what are the major challenges that you face? I know you've talked about what are the some of the challenges you face in GTB, but why doing migration from on-prem to the cloud? What are the issues that you face? If you can just tell us some, just for
Okay,
us to
yeah,
learn.
yeah. So the first core issue was, you're moving from one system here to a different system totally. You
Yeah.
understand? And
Yes.
two,
Yes.
secondly, you have to look at the application compatibility too. There's some the way this core legacy system was built, and also the way the application was built too. You have to understand them and pick out how compatible they are. Then the data itself, those data that you have, how do you map them? Do you need to move all the data? There's some data that you feel that is redundant. So some situation whereby you are mapping from maybe from Oracle system to SQL Server. That sometimes how do I put it? The way they define the data in Oracle might be slightly different. So when you're trying to do your conversion, you can run into a lot of mess because of, oh, maybe the data was stored in this format, let's say big int or something like that, and you're trying to do your conversion to the current system. You might run into, so those are the kind of issues we run into whereby you are trying to convert. So what we did was, okay, fine, let's have like a staging environment whereby, okay, we can pull down to that place, do a lot of transformation there, then move it to our final destination. So that's one of the
Yeah.
solution we brought in. And from there, you start looking at, okay, and also you don't have to, another thing we should also look at is you don't have to miss out on some core data. You understand? Because as you're also migrating, you should stage it sequentially. As the system is also working, people are updating record, people are still doing the business as usual.
Yeah.
You
There
have to
should be
like
a
keep
syncing
track of,
between them
there should be a syncing between your on-prem system with the system you're
and the
moving
one on
into.
the
So
cloud.
it's a very, very, and sometimes when you're working, there's some problem you didn't even plan to get, but along the process, you just encounter them. So then you expose yourself to, okay, what are the trade-off we have? What kind of, you have to discuss with the business guys. How important is the data? Do we need to let it go, or do we need to just keep it in a cold storage? Sometimes you have to set up like an S3 bucket whereby some data we feel like we don't need in the current system. We just move it to that
Okay.
bucket there. So in case they need it in the future, you come and
They
you
can reference it.
can reference it. So
They can
those
make
were
use
the
of it.
things.
Okay.
Those were the things we will consider along the long run. But it was a lovely experience then because it was something totally different from what I did to something I'm coming and like, okay, how do we work on two different system and make sure, because if you in the financial system, if you make one little mistake, it can mess up things
Yeah.
because of a lot of data governance and a lot of sanction that might come in. So I think those experience like exposed me to understand this is a big space. You have to get your hands dirty and try to work with the business. Yeah, you work with a lot of people. You have to work with the business people to understand what they want. You work with the software team, and you work with your own infrastructure team to like, okay, so that you guys, as you're making your own recommendation, you also put in their own position about it. So those are my experience, and it was a lovely job because I get to learn a lot about data migration, data modeling, and mapping data from different system to another system. Was a very intriguing moment.
Interesting. Yeah. Okay. Thank you for that. I also noticed that there are while working in a parastatal government parastatal in Nigeria, there was a reason why they mentioned that their data should not be outside. I mean, outside of the country, and I also think that doing data syncing um from one particular data recovery site to another one, I think it's one of the things that we also leverage on at that point. Should in case something happened, we so much believe in the cloud, AWS, and I think is it few days or few weeks back,
Yeah,
AWS
a
was
few
down.
yeah, there's
AWS was down a lot.
even few days back, Microsoft DNS service was
Yeah.
out. So yeah,
so
but
so a
those
lot
systems
of
too,
things.
they have their own data center. So just like conventional with the way say when you have your own data center, but the more they have it in a more like large scale whereby they can provide service to other people. So not that like their own system doesn't have its own fault, but that's why they give like availability of 99.9%. That 0.1% can fall in at any time. So you also have to
Hmm.
put that on in place too. Yeah.
So I know that you've worked on machine learning to do some stuffs, right? Uh, are you able to apply, or have you applied that machine learning models or processes into your data reliability?
Oh
Have you
yeah,
done
yeah,
that
yeah.
yourself?
So yeah, machine learning itself is more like trying to build a system to understand your data and
Yeah.
make decision based on the kind of data you've imputed. So I yeah, along the process I've worked on several machine learning models, even in my master's degree. I've worked on several machine learning models, and so for you to build a very reliable machine learning system is how trustworthy your data is. I think you sent a reference about trustworthy AI, like how trustworthy your data is. You don't just feed in any kind of data, just pumping data. That's why you see in the
Okay.
recent trend of machine learning too, the field of data engineering becomes more and more relevant because to build um, a reliable machine learning system like the conventional LLM system, which is more like next text generation, because those things are based on like you put in your data, they create their embeddings, they try to check the relationship between two different embeddings and make prediction based on and rank them. So now, how do you feed in your data? For example, now, let's say for example you have like a coding problem. Maybe you want to let's say you pick up a lead code problem or a coding problem, and you pump in those prompts on different machine learning tools like LLM AI tools like Gemini, ChatGPT, Claude.
Okay.
You see, each of them pump gives you different kind of solution. You understand? So those things are based on how they were trained, how they place the weight on different kind on their models, and the kind of data they feed those models with. So machine learning system is reliant on data itself. So that's why data reliability is very important in building a machine learning system or a machine learning model. So you look at, okay, what are the kind of data do I need? Who
Okay.
who are my target? Let's say, for example, you are dealing with health. So when you are dealing
Health
with, maybe
data.
you want to build a chatbot for an health recommendation system, you don't need to start feeding it with something outside of it, like maybe
Yeah,
something
totally
like
different.
entertainment. Yeah. So you have to like fine tune your data, pick the most important things you need to do. Then you you push it into your system, check the feedback. Where from there you begin to okay, make adjustments from your system and keep is a
Improve on
continuous
it.
process. You understand? So
Yeah.
data reliability, you look at what kind of data am I pushing into my system? How do I clean up some dirty data, something that is irrelevant to the system, that I push in
Okay.
the right system, and not just pushing in garbage data, but pushing in data that you've designed in such a way that your machine learning system can understand the relationship between one another, then how do I design the data model? You understand? Maybe you are trying to build a machine learning system for like voice recognition. You can't feed it with normal text data. You understand? You try to pull in data whereby people use their voice, audio
voice.
data, maybe video data, whereby from there it can learn the
Can use it to train it.
to train himself. You understand? If you
Yeah.
want to build a multimodal system, you can now pull in, but there's a way you design your system to like pushing those data that you can use to learn itself. You understand? And how do you want to design your system? Maybe you're trying to build, because I work on a graph machine learning model. Sometimes if you want to build like a graph machine learning model, you have to design your data in a graph form whereby this data relate with one another, or this person, this
Okay.
and this node relate to this node. So when you design it and you push into your system, it's more easier for your system to build or train machine learning on those models. So reliability comes with, are you pushing in clean data? Are you pushing in necessary data? And how frequent your data is being updated, because you have to keep like when you monitor your machine learning model, see the feedback and see new, because data you get data every day. You understand? And if you the in the next few years they are trying to build a system that is well more intelligent. But to have a well more intelligent system, you have to like how can you pull data from different states? How can you pull data from
Different
motion? How
source.
can you pull data from how things move around? Sensor. So those are the way machine learning system are built, and they are their core their core back end is how you design your data for it to train on.
Yeah.
And if you feed it with bad data, it pumps out weak
Bad data
models
for you.
inside. Yeah. So
Yeah, it's yeah,
that's
continue, continue.
for me, that's what I was saying about the next level technology, and how we design our data system and how we set up our data system to build something bigger in the future.
Okay, okay. Because with the way AI is moving now, a lot of people are even going into building their own models, training their own stuff, just basically to just tie it towards a particular sector. For example, while working on investment, you don't need to train your AI with entertainment, or it needs to
Yeah.
be related to that particular stuff that you're actually trying to implement. And with it, I think it also helps your system, right? In form of you give out the actual or the expected uh, data that people are actually looking for. So like we discussed, because if you're using for example, you're using AI for coding, and they didn't train that particular AI very well, what you'll be getting will be
Yeah.
bugs,
Yeah.
right? That you have to you have to be debugging and trying to
Okay.
fix it. So why building something that is not actually relevant for people to use? Thank you for that. So in regards to startup, right? Because I believe most companies are some startups are actually using AI to improve their application, to improve their workflows, right? So what do you think is like a data reliability way for a startup to implement and to incorporate into their solution? Like so what I'm saying in essence is that as a startup, we are leveraging on AI, but what are the things that we need to focus on when building, when continue with our application regarding the data reliability?
Okay. Well, in startup, in startup, people just focus on more about pushing out the product. You understand? Also, now when you now push out the product, maybe the product scales so well, then the way the system was designed, it fails to handle those kind of requesting some. As you're trying to build in your future, your nice front end, your nice application, you also have to understand, okay, how do I design my data models? So the first
Okay.
stage of data reliability is more like designing your data models, trying to know, okay, what kind of product am I pushing out? How do I design it so that even though I want to scale tomorrow, you understand, you don't have to come back and tweak in your models completely instead of making those few adjustments. So you have to like start from scratch. Like you have to like understand what product I'm pushing in. How do I design? Let's say the core system. If you want to build like a normal system, you have this what we call the normal ER diagram, the entity relationship, whereby okay, these are the entities that we are looking at. How do we relate to one another? So that's from there you start building your tables, different tables that join, the schema model you want to build. You understand? Are you
Yeah.
normalizing your data? What type of normalization form do you want to use? Is it a third NF? Is it a boys cost NF? So from there, if you can build those kind of system, then what is that system doing? Is the system
Okay.
for, you have to know, is it just for maybe for prompting or for reaching out to, you have to understand what the system is built upon, right? Well, that's what will give you understanding about how to design it. Then also you have to look at the future scalability. You understand? In this system, trying? Am I will I have to build a scalable system, like maybe whereby I can keep store different data in different system, like data sharding. What kind of storage system, like you have to like look at those kind of technology that will be very, very relevant. You understand? For example, there's sometimes some top firm like Uber, sometimes they'll move from one core system to another system because of how it was built earlier and the current way it was
Initially.
working initially is not efficient enough. So you will
Yeah.
face those kind of challenge. So you have to understand the basics. And also in the long future, in the long run, some kind of feature you want to add, you understand that, oh, this system will not be able to deal with it. You have to now migrate. So the first step is understanding your data model, design it efficiently, and also add in the mind, if I'm scaling, how do I want to scale? Do I just want to scale by adding new resource, or do I want to scale by distributing my data into different platform, into different server? So those are the few ways. And also you have to look at in the age of AI, what people do in some startup, you can just call some AI APIs. As you're calling those APIs, you also have to look at your own data that you have. How do you fine
Okay.
tune them? You use your data to fine tune the model you are calling to make it work closely to what you want. You understand? Because those models too, they are
Okay.
built on some certain kind of data, but you can still fine tune them by pushing in your own data from your customers base to give you like maybe prompting. Maybe, for example, you want to help like a chatbot on your application. How does a user get help? So those are the ways you start building reliable system. How do you keep your data and that thing? So also data storage. There are some ways you can store data. There's some data you keep in the hot
Okay.
storage. There's some data you keep in your cold storage. When I was talking about cold storage, like, okay, you just go there, retrieve it once in a while. Why the hot storage, whereby it's being updated frequently. So
Yeah.
once you understand those ways, you can now start building okay system. In the future, if you want to scale, it's more easier for you to scale without trying to make significant changes.
Okay. Okay. Oh, thank you for that. Because one thing that I've also noticed or learned is that when you're doing you're building a system that is going to be used globally, there are some other things that you need to consider, like you built a solution in Nigeria, but you want to scale it to maybe other African countries. You also need to fine tune and make sure that is scalable whenever you are moving to that particular country, so that it won't be like you are redesigning afresh. I also noticed that which when I'm building solution now, I also factor in all
Yes.
those kind of criterias, because your system basically, we if you want, you are building for the world, you need to fine tune it and make sure that everything, uh you can make it like uh pick and drop, so that it won't be like you are you are redesigning the entire system all over
Exactly.
again.
I think if even our experience in BFC, sometimes as we are building for Bahrain, you're also building for Kuwait, you're building for other
Yeah,
system, you
yes,
understand? So you don't have to like start redesigning for each subsidiary in a different country. You just have, okay, you have this model, you have this prototype here. You just replicate the prototype, and you might have, based on each country data policy or data governance policy, you have to like, okay, adjust some things. And that's it. I think that's another core thing when building a system. You have to like have
yeah,
a vision of, if I'm scaling out of my local base, how easy how easy for me to add other entities, you understand? So I don't have to come back and start, okay, how do we redesign the
designing,
system again? And that is a big work. And sometimes there's a way you redesign a system, it will affect your core system. So
yes,
you don't want to do that when you have a very, very significant customer base, you understand?
yeah, yeah. Thank you so much for that. Thank you so much. uh so when when a user, or let me put it like this, someone that is trying to go into database, data engineer, and the likes, what are the things that you believe are like, because all these things follow a process. You can't just wake up today and say, okay, I'm a data engineer. What are the things that you believe, or what you pass through before you reach this particular stage? What do you think a young user that wants to go into data engineer, what do you think they can actually plan, as maybe a 4 month program, a 6 month program, a 1 year program, for them to basically learn? What do you think they can do regarding that?
Okay, yeah, yeah, okay. For maybe a new coming into tech and trying to understand the tech world. I think the first stage is to like maybe the field you're going to, let's say, because I've spanned through database administration, SRE, data engineering, you understand? So you have to understand you have to understand the core duty or job role of those field, you understand? In database administration, what you're trying to do is trying to deal with how your infrastructure for the data and how you design your system in such a way that the application can frequently access it, and also how to make your system more reliable, and how to keep making adjustments, performance tuning, monitoring to improve your system. So firstly, if you want to start, maybe you want to start with database administration, you have to understand, firstly, you have to understand how a a large system, a large organization, how they design their system or how they design the data model. That's why I talked about entity relationship here. So before you even get to
Yeah,
that part, you have to understand, okay, what type of system, what type of functionality is it data based for? Is it for OLTP process or OLAP process? OLTP means the conventional way, frequent write, maybe just like your banking application, but you just come, you pick, you transfer money from Mr. A to Mr. B. This one is
Sabi,
debited, while this one is credited. So in that
correct.
case, you have keep updating the system frequently. You understand? Then why in an OIP system is more designed in such a way that you design the system whereby you is purposely for analytical process whereby you try to join different data from different resource and build a analytic system. So now once you understand that, you then understand how are they designed. If you're looking at the OLTP
Okay,
system, you have to understand that, okay, you talk about the third form normalization, the boys cost normalization. How so those normalization means that instead of you keeping same data across different table, you can keep it here, then reference it, the primary key and foreign key relationship, stuff like that.
yeah,
And also there's some kind of data that okay, you don't want them to make changes, or you just want to keep them in a predefined way. You have to understand the constraint. So those kind of things, you have to understand how data is being designed, database design system, how are they
okay,
designed? and the purpose of the system itself. Then also after that first phase, you understand that the next phase is how do we retrieve those data? That's where SQL comes in. You understand when you're working with a relational database model, you have to understand the core system about this job role is you have to have in-depth knowledge of how to write SQL query, build SQL query, maybe build procedures,
Functions.
build functions, build
Yeah.
triggers. You understand? You have to
Views.
understand
And like,
those in views. Why do we build them? You understand? Why do we
why do we
build
need them?
views?
Yeah.
Why do we need them? Views are mostly when you build them, it's more like okay, you don't want to keep writing the query over and over. You just point to that view, it runs and gives your data.
Make it.
Procedure, maybe your procedure is to do some kind of certain functionality when maybe an application calls it. Instead of the application writing the code from the application end, you understand? But the procedure is being
Yeah.
stored in the system. So you have to understand those functionalities. How do you build them? How do you fine tune them? You have to understand when you run an SQL query, what are the steps in the SQL takes? What are the first thing it checks? Is it the join first? Is it where? Is it the having clause? Is it the group by clause, having clause? So you have to understand those steps about SQL, how to retrieve your data. Two, performance tuning. I'm talking about the database part. Performance tuning is okay. Performance tuning can come in different way. How do you write your SQL query so that it doesn't pull irrelevant data? You understand? You write in such a way that it pulls the important data you want. And how do you store it? Like you have to talk about indexing your data, then the B-tree indexing so that instead of you scanning through your whole table, it picks the important information it needs, right? So those are the first steps in building SQL. Then also you have to understand maybe several how to fine tune several database system. There's a way you fine tune Oracle system. There's a way you fine tune Postgres. And with the recent features from cloud system, sometimes they build some in-house model like machine learning
Model
system
that
to
can
understand
interact
that
with.
interact with that helps you fine tune those things. So once you understand them, then you understand how do you design it in a scalable way, like the availability, the distribution system. You understand? You have to understand different kind of distribution theorem, like the CAP theorem. You have to understand, okay, what is your core? Is it availability and consistency? You understand? Is it fault tolerance? Fault tolerance. So you have to understand those things. You have to understand
What
how
the
the
person is
system
actually trying to achieve.
trying to achieve. You understand? So once you understand
Okay.
how the system is built, how you can do, they have to understand about monitoring system. How what are the things I need to put on my monitoring system? What are the things that I track? You understand? Then how to steps in troubleshooting problem. You understand? For the database engineering part. So if you come into SRE is more like you provisioning infrastructure for data system. You understand? Then you have to understand how to work with automation to you understand like
Okay.
Ansible. Like instead of you trying to
Okay.
do a process all over again, you write your code or in a playbook that just run it. You have to like learn how to. Each of you, when you're working on cloud platform, how do you provision your system? That's where like tools like Terraform comes in that helps you provision your system. Whereby you have like whereby you can write your code, provision your system, and you can use it at different environments. Maybe your prod environment. So it helps you keep track of things. You understand? So then also you have to now look at how do I provision resource to my system for SRE and how do I do monitoring. Then in data engineering, the data engineering role is more like you pulling data from different source from
Okay.
because system are built and they have many products. They design different data. Sometimes they have like your normal relational database system. You have some system whereby more of IoT system. Just why some system are more like they are schemaless. So let's say some system that is based on JSON design. Let's say you are working on MongoDB like NoSQL system. So you are pulling data from different source and you are pulling it to another source so that you can present the data maybe to a machine learning team or to a business analytics team. So you have to understand, okay, how does different system design their data? What are the tools I can use to connect from one system? The
To another.
your nervous system. They have to understand how you design your data pipeline or your there's this medallion architecture whereby you move it from one system, tune it, tune it again till you get your final recipe. So once you understand different system, then how do you move your data? Is it batching? Batching is like, okay, it's more scheduled at a timely interval, maybe hourly, 2 hours or end of day. There or is it a streaming system? Streaming system is like continuous update. Let's say, for example, in messaging too, maybe when we are in GT
Okay.
Bank, when you do your transaction, you get alerts. So those are not like a streaming system. You make the changes and it goes to a system that push out those alerts. Yes, and those you
Okay.
have to understand those things and how which tool do you want to use? Is it on a cloud base? Mostly, it's only on a cloud base.
Or
What are the
cloud, yeah.
two used for? You understand? If you're like, for example, I work on AWS too. Mostly, we use Athena, S3 buckets, Glue. The Glue is more like you trying to check if there are updates. Pulling data from different source. You can run you can design your data lake on S3, create on Athena. So you have to like understand how the system is being designed, what tool you are designing, and you have to have deeper understanding about data warehousing. Data warehousing
Okay.
is, data warehousing like you pulling data from different sources now. As
Sources.
you're putting
Okay.
this, you are not like, okay, how do I design my system? You
To
have like the
accommodate them.
star to accommodate them. You have the star schema. You have the snowflake schema. So those systems, like maybe when I was talking about normalization in OLTP, those systems are already normalized. Do I need to denormalize them? Do I like you pick those data and join them so you don't do those things are so you don't do excessive joins. Excessive joins are computational bottleneck sometimes when you join from server table. Instead of you doing that, you can have like a big table whereby all your data are there. So once you just run your query, you just select from each of the column you need those things. So those are the kind of ways you have to understand. So firstly, if you're coming to the data world, you have to understand how data is being designed. You have to understand the purpose. You have to understand the reason behind it. And you have to understand the tool you are using. For anybody into the data world, firstly, the one that is non-negotiable is SQL. You understand?
Mm-hmm.
SQL is non-negotiable. Then the programming tool, you have to like, if you want to come into data engineering, you have to like write code because your code, you might pick data from different sources. You deal with APIs whereby you transform them. Maybe you can
Okay.
pick Python is more. Then also
I
you have
think
to
it's
understand
more easier to use because
more easier to use. I think
there are quite libraries that are available to just incorporate and use. I know, I know,
so.
I know.
Yeah, there are libraries whereby you can just push in their features or their module and just do your transformation and stuff like that. So I think Python. Then the next thing is if it's data engineering, it's more like the orchestration tool that you're trying to use, depending on the kind of orchestration tool you want to use. Also, you have to have deeper knowledge about this current world. We are now having like more like instead of data warehouse, I think people are now doing a data lake system or an iceberg system whereby the data you can also do like a schema based data lake system. I think something like that. So you have to like understand the newer technology. Maybe if you're working on
Yeah.
Azure Databricks, or if you're working on Snowflakes, why are they used? And also the way your data is being stored. Is it more like a row based storage system? Is it a columnar storage system? So those things now give you understanding on how to build solutions. Once you understand how each
Yeah.
system works, then you now look at, okay, if you have a problem, sometimes some kind of solution, some kind of problem does not need complex solution. You just need to like, okay, maybe just a batch process. You just need
Understand.
to just like a bash script. You need to just write. I just put from here and here, or you just like need to write some lambda function, or some system, some kind of problem need you to fully design a big
To
data
to develop.
architecture.
Yeah.
Yeah. So
Yeah.
from there, when you have
It
the
all
understanding of the
depends.
core underlying system, you you'll be able to now provide solution about it. You understand? So I think those are the core skills people need to build before diving into each of those
Okay.
roles.
Okay. Okay. Thank you so much. To people listening to us, I think you've picked one or two things. If you want to go into database, data engineer, there are some things that you basically need to learn. There's some things that you need to know ahead of time before you can even move to that particular role. So you like Godwin has mentioned, I think you can pick one or two things from there and you just be able to achieve what you want to do. I think so. So
Yeah.
it's a good one. Uh I want to ask you if you can give an advice, last advice, to people who listening to us on YouTube, Facebook, and other social media, regarding data, how they can make their data reliable. Data reliability doesn't mean that it's only application. Even you having your contact on your phone, that's part of data. That if something happens to your phone and you didn't store it somewhere, maybe you didn't store it on Google, that's the end of that data. So maybe you can just give an advice, just one advice to people listening to us.
Okay, I think in data, in one of the core advice in when you're working on a very, very delicate system or very, you have to, how do you design your system such a way that it's easier for you to retrieve information? That's more
Okay.
important in the business. How do you design it? You have to look at, okay, this way I'm designing it. Is it easier for me to retrieve this information? The way I design my system, just like maybe in your phone book list or even in your Windows Explorer, you have different folders for different things. So in case, oh, I want to pick this file. Okay, this is the folder it should be. You just go directly to the file. Less time, you don't spend more time scanning all through your this thing. So
Yeah,
what
that's
you just
true.
need to do like, okay, how do I design my system? Once I wake up at any time, I can pull something out without checking all through my files or my phone book. You understand? So two, your availability of your system is very important. How do you design your system that it will be available, to be fault
Hmm.
tolerance? Should in case there's any failure, it's not a single point of failure. You understand? You have
Okay.
to understand, and also you simulate problems. You understand? Because then when we're working, there's a time whereby you do like you simulate whereby you fail over to this system to check where your secondary system is it efficient enough to run in that same
If
capacity
primary
or
data
yeah.
is done.
So those kind of things you have to like look at the core thing, design your system for easy so for someone to easily retrieve data. Two, you have to understand how available your system is, you understand? And also you keep trying to see newer technology and how to improve performance of your system. I think those are the core three things about data reliability. It's about designing systems such that it's efficient in the long run, so that the system is available and system so that it's scalable enough when you add new features. You don't need to do a new design. I mean, that's one of the core bases here when you're working in
Okay.
a in a corporate system, because
Okay.
nobody wants to touch something that will mess up the whole.
The entire
Um,
the
yeah,
entire I
so
understand.
it's a mess. You hate
Yeah.
yourself. You understand? So is that's one thing. That's one principle I work with. If I'm trying to build solution now, as I'm designing the system, if somebody comes into the system, would they, is it easy for the person to understand what I just did, or for the person to like okay add new features to it? Is this system available enough? Is not a single point of failure? And also, can we make it scalable with less stress? You understand? So, I think with
Okay.
the recent new AI the data world has come to stay, and the field in data engineering, anything data,
We continue to
we
exist.
continue to use it because you
Because
need to.
everything regarding AI now is backed by data. So data will
Yeah,
continue to to be relevant.
because there's no AI model that is not trained on any data. You understand?
Yeah, that's
So
true. That's true.
there's literally no AI model that is not trained on any data, and we know AI is coming for the jobs, but I don't AI cannot generate its own data itself because
It's not possible. That's
data
not
are
possible.
users. You know, you're trying to understand the users. You understand? So they are just user based information. You understand? So that's the thing. So I
Okay.
feel the field of data has come to stay for the long run and becomes
Yeah,
more
I believe
relevant
so.
with new emergence of AI tools.
Okay. Uh so let's to our listeners, thank you so much. Thanks, Godwin, for the insight. I so much, I so much believe that a lot of people have picked one or two things from this particular conversation regarding the data reliability and AI. And I so much believe that there are a couple of things that, like you rightly mentioned, there are a couple of things that I'm also going to incorporate into my designing when building a scalable system that will make it much more reliable, not only the software part, also from the data part. Thank you so much, everyone. Thank you so much. I really
Thank
appreciate
you.
your time. And till next time that we're going to meet on this Tech Niger FM show, like I do say, keep building, keep believing, and I so much believe that you should stay awesome. And whatever we are building, let's just put in our possible best. Thank you so much, and all the best.
All the best.